So today we are going to do a couple of problems from Gauss-Jordan method. So yesterday I briefly told about uh, the Gauss-Jordan method differences with Gauss elimination method. So let me take a simple example. I told you yesterday, I remember that the difference here is that we need to get an identity matrix or a normal form kind of matrix. So example, a simple 2 cross 2 will do 3x plus 5y equal to 9, 2x plus 3y equal to 5. So the step 1 for this is to create the augmented matrix. So which looks like this: 3, 5, 2, 3. You put a colon or just put a vertical line. This is your augmented matrix. So I said that in plain Gauss elimination, you just have upper triangular matrix, but here we need to make it as identity matrix. So yeah. So first, let's keep that matrix here. Now I need to make this as 1. This is the pivot element, what we call here. So R1 goes to R1 by 3. That leads to, I'll put a tilde to say that this elementary row operation gives rise to 1, 5 by 3, 3, because 9 divided by 3 is 3. So instead of the colon, this is standard, colon is standard, but I just put a vertical line to save time. So yeah, so now this second row as it is, we don't change anything here. Now we using this pivot element, we make the first column 0. So R2 goes to R2 minus 2R1. That leads to, this tilde implies that this row operation leads to 1, 5 by 3, 3, and this becomes 0. This 3 minus 5 by 3, you can check it, it becomes minus 1 by 3. 5 minus 3, 5 minus 2 times 3 is minus 1. Did I make a mistake earlier? 3 minus 2 times 5 by 3 is minus 1 by 3. Okay. So yeah, till now good. So what is the next step? Next step is to get a 1 here, right? So if I multiply R2 to minus 3 times, minus 3 to minus 1 by 3 becomes plus 1. So I'll do that here. So R2, I will rewrite it as minus 3R1. So my new matrix is 1, 5 by 3, 9 as it is. Second row is what I'm doing now. The 0 doesn't get affected because it's a linear operation. This becomes plus 1. Remember, minus 3 times minus 1 by 3, 3 gets cancelled, minus into minus plus, so it's 1. So that's what happens. So similarly here what happens, 3 times minus 3 is, no, it was minus 1 earlier. Yeah, it was minus 1, now it becomes plus 3. Sorry. Yeah, so now what we do, my next step, only we have one step left out, that I need a 0 here, right? So what I do, I multiply R2 by 5 by 3 and minus it from R1. So what I'll do, R2 goes to R1 minus 5 by 3 R2. That leads to the first row is same. Sorry, I made a mistake. It is, I'm not doing it on R2, I'm doing it on R1. So I made a huge mistake, sorry. So this is what I was aiming at. So this has to become 0. So this becomes 0 and this is unchanged. So what happens here is R1 minus 5 by 3 times R2 is 9 minus, okay, let me do it. 9 minus 5 by 3 times 3. Did we make a mistake somewhere? So it was 3. Why did I write 9 here? So I think I made a mistake. Yeah. This was. So if we followed it from the beginning, I think previous step it was 3. So it should have been 3. So I should not say 9 here. I should say 3 here. So this is 3 gets cancelled. 3 minus 5 minus 2. I get a minus 2 here. So let's even try to verify. Verification I'll do. So my equation was what? For example, my first equation was 3x plus 5y is equal to 9. So I'm getting the values. This is the final answer, right? So if I put 3 into minus 2 plus 5 into 3 equals minus 6 plus 15, which is 9. Yeah, this is satisfied. Let's also try to check the second verification of second. By the way, the exam verification is not required, but I'm just saying second equation was 2x plus 3y equal to 5, right? 2x plus 3y, this was the equation, right? So let me verify this also. So 2 times minus 2 plus 3 times 3 equals minus 4 plus 9 equals 5. Yes, we have verified. Okay, so verification successful. Okay, so we have done a very simple 2 + 2 example. I'll try to quickly also show you a, a bigger example. Maybe that's what this is very algorithmic. Like you go on taking the pivot element, and then the pivot element is right in the left hand side top corner, and then make all the below number 0, that column. Let's go to pivot element in the second column, second position. So second row, second column, that position, make it 1 and make everything else 0. So that's the algorithm, and that's why it can be implemented on a computer by any language also. So here's a problem. So if you follow it properly and make a code, even if it is 100 cross 100, that is, even if there are 100 equations with 100 variables, still the computer can generate. Of course, humanly it is tiresome, but computer can do it. So here's a problem. Let's say we have 4x1 minus x2 is equal to 1, minus x1 plus 4x2 minus x3 is equal to 0, minus x2 plus 4x3 minus x4 equal to 0, minus x3 plus 4x4 is equal to 0. Look at this. The matrix corresponding to this will be like this. What is that? 4, that is for this x1, minus 1 for this x2, 0, 0, because see, you have to go till fourth variable here. Okay, and as usual, I'll write a vertical line. That's what I'm more comfortable with. And the right hand side for the first equation is 1. Second equation is minus 1, that is for this, 4 for this, minus 1 for this, that is for the third element here, and then 0, 0. Then 0 minus 1, 4, 0. Then 0, 0 minus 1, 4, 0. This is your augmented matrix. Let me write it down. Augmented matrix. Now I'll take this augmented matrix and let me write it once again. 4 minus 1, 0, 0, minus 1, 4, minus 1, 0, 0, 0 minus 1, 4 minus 1, 0, 0, 0, minus 1, 4, 0. So I'll quickly tell you R1 goes to 1 by 4 R1 because I want to make the pivot element 1 here, this element. So it becomes 1 minus 1 by 4, 0, 0, 1 by 4. Rest all same. Yeah, rest all same. So now my job is to just make a 0 here. I told you just a while ago that all the elements below the pivot element should become 0 in the first column. That's my step 1. So R2 goes to R1 plus R2. So if you add these two, it will become 0. So you get 1 minus 1 by 4, 0, 0, 1 by 4. This becomes 0 now because I'm adding these two. If you add these two, you'll get what? You will get 15 by 4. I'll demonstrate quickly what is this. This is 4 minus 1 by 4 equals to LCM 4. 1 4 4 4 16 minus 1, 15 by 4. Right? That's the 15 by 4. The next is if you add this to just minus 1, 0. Here if you add this 0 with 1 by 4, you get 1 by 4. Rest are same. Rest are same. Next what I do? Next I do, because I want this column job is over. Now I want to get a 1 here. Remember my diagonal should be 1. So I do R2 goes to 4 by 15 R2. So we get 1 minus 1 by 4, 0, 0. I'll write a little tiny so that I can fit it here. 0, 1 minus 4 by 15. Please verify. I'm doing it very quickly due to paucity of time. 0 minus 1, 4 minus 1, 0. Because the rest, third and fourth rows are same. right? So now remember this matrix, take down this matrix now. I'm going to again do row operations to make this position 0, this position 0, this is anyway 0, right? So this I'll do R3 goes to R3 plus R2 and R1 goes to R1 plus 1 by 4 R2. By doing that, what I get is this first row as it is. No, first row is also changing. R1 goes to R1 plus 1 by 4 R2. Second row is actually as it is. So 0, 1 minus 4 by 15, 0, 1 by 115. Third row I said R3 plus R2. So that will lead to 0, 0, 56 by 15 minus 1, minus 1, 1 by 15 again here, 0, 0 minus 1, 4, 0. So if this is not that clear, let me change it a little. 56 by 15 it should be. Okay. Now the next thing is that I need, so we got the second column in the required format. Next is I need this position 1. So what I do, it's the operation will be done on R3. R3 goes to 15 by 56 R3 because I'm reciprocating it so that I get a 1 year. So we get, this is as it is. Here I get 1. And here minus 15 by 56. Why? Because I'm multiplying by 15 by 56. And here it is 1 by 56 because 15 gets cancelled. I will not change anything else except the third row. Okay, so please note this. This is the latest matrix after a lot of row operations. I think we are almost close, except that column has to be set, right? My goal is to get identity matrix. So my next operation is going to be R1 going to R1 plus 1 by 15 R3 and R2 going to R2 plus 4 by 15 R3 and R4 going to R4 plus R3. So if I do that, so whatever I get is the new equivalent matrix, namely 1, 0, 0 minus 1 by 56, 15 by 56, 0, 1, 0 minus 1 by 14, 1 by 14, 0, 0, 1 minus 15 by 56, 1 by 56, 0, 0, 0, 209 by 56. Please get this computation. Do it by yourself. You'll get no. So we are ready to now operate on the final column now. But we need a 1 year. So to do that, what we do? R4 goes to 56 by 209 R4. So we get the following: 100 minus 1 by 56, 15 by 56, 010 minus 1 by 14, 1 by 14. Remember, I'm doing it only for the fourth row, so third row is the same. Minus 15 by 56, 1 by 56. Here comes a change, 0001. And here becomes the 56 gets cancelled. Yeah, and what remains is 1 by 209. So we are almost ready, except that these three elements have to be made 0, which I'll do next. One final operation will set it right. What is that? Not one, rather it is like we should do R1 goes to R1 plus 1 by 56 R4. R2 goes to R2 plus 1 by 4 R4. R3 goes to R3 plus 15 by 56. So these three operations we require because those three positions I need zeros. So we get indeed 1000, 0100, 0001. Sorry, I made a mistake. 0001, and we get here 56 by 209, 15 by 209, 4 by 209, 1 by 209. So like the previous problem, here also you can verify. We finally successful in getting identity matrix. So this is exactly Gauss-Jordan method. Gives x1 as this value 56 by 209, x2 as this value 15 by 209, x3 as this value 4 by 209, x4 as this value 1 by 209. So we got x1, x2, x3, x4, all four values. We can verify it. So that's all. So I'll end the class here.